So let's start. So today we will discuss uh, one of the previous exam. Okay, we will start with the Python question. Here you can see what will be the output of the following snippets of Python code. Write down the exact output, including all brackets, parentheses, braces, chords, and commas. Okay, here they provided a list. The name of the list is X. The elements of the list are Oman, Qatar, Bahrain, Kuwait, KSA, and UAE. So here you can see they ask you to print X. So all the elements will be printed. And they just use the print statement. They didn't use the for each statement. If they use just the print statement, it will print all the elements in one line. Okay, this is what you can see here. All the elements are printed in one line. Okay, now x dot append. You know what is the use of append method? To add one element at the end of the list. Okay, so here this is what they are going to add. This is the argument of the append method. So here you can see we have a string Lebanon. Then it is joined with another string 1, 2, and also it is joined with another string. It is H. Okay, so here all the elements will be joined and that element will be added at the end of the list. Okay, so here you can see after that they wrote a print statement and here what they are printing, they are printing x of 0 plus 1 minus 2. So 0 plus 1, 1, 1 minus 2 minus 1. So that will be x minus 1. That means the element at the end of the list. Okay, so what we added now, we added this string. So that is the last element of the list. Okay, that's why here it printed Lebanon 12H. Do you understand?
Yeah.
Okay, and here you can see we have a list called X, and then we use the concatenation operator, and then you can see one more list, and that list contains two elements, Egypt and Jordan. Okay, so what will happen? The list X will be joined with this list. Okay, so this is the list X, and we added Lebanon 12H. So this is the current list, and Egypt and Jordan will be added, or it will be joined to the old list. And now they ask you to print X. So all these elements are there in the list X. Okay. So this is the output of the last print statement. I hope you understood. If you do not understand, just let me know. Clear?
Yes.
Okay. Now we have the next question. They provided a list called M, and these are the elements of the list: Lexus, Toyota, Nissan. And here you can see N equal to list of M. Okay, so here we have M, and if you write list of M, a new list will be created. Okay, so let's say this is the new list, and the name of the list is N. And what will be the elements of this list? Here, what is the argument of list? The argument of list is M, which means that all the elements of M will be copied to N. Okay, so here we have Lexus, here we have Toyota, and here we have Nissan. Okay, so this is the list N. And here you can see we wrote O equal to M. So if you write O equal to M, uh, O will not be created as a separate list. Here, O equal to M, which means that O will refer this list. Okay, so now you can see both M and O refer the same list. Okay, but N, it is a separate list or it is a different list. Okay, now look at the next statement. M dot append data. So data will be added to the list M. So here we have M, And here we are going to add one more element, that is data. Okay, so that element will be added to M. Okay, and we have a print statement, and here you can see this is they used the format method in the print statement. Look, what are the arguments of the format method? The three list. M is the list, N is another list, and O is the another list. Okay, so it will print three list: list M, list N, and list O. Okay, and here you can see we call this as the placeholder. Okay, that means 0 corresponds to the first argument of the format method, that is M. 1 corresponds to the second argument of the format method, that is N, and 2 corresponds to the third argument of the format method, that is O. And here you can see after each placeholder there is /n, which means that each list will be printed in a separate line. Okay, you know, /n means new line or separate line. Okay, so first it will print M. What are the elements of M? Here you can see these are all the elements of M: Lexus, Toyota, Nissan, and Tata, because we already added Tata to the list M. Okay, so it printed all the elements. Then 1 means that N will be printed next. So you can see this is the list N, and here we have Lexus, Toyota, and Nissan. So it printed all the elements here, and the last element is O. So here I already explained O equal to M, which means that O refer the same list of M, or both O and M refer the same list. Okay, so it will print the same elements of M, that is Lexus, Toyota, Nissan, and Tata. Okay, I hope you understood. One more thing that you
I
need to
have two
yes.
questions.
Uh-huh.
First, n equal list m. This works like a copy method.
Yes. It will create
Okay.
a new list. It will copy all the elements of M to N.
Okay, in the print statement, if I didn't use the /n, it will be printed next to each other or not.
Yes, it will print all the elements in the same line.
Okay, thank you.
Okay, okay. So whenever they ask you to print a list, you have to use the square bracket like this, and then write the elements in quotation if it is a string, and you have to use comma between each element. Okay, because if you didn't use the square bracket, if it is a list, if you did not use quotation, and if you did not put comma, you will be deducted marks. So make sure that if it is a list, use the square bracket. If it is a tuple, use parenthesis. If it is a set, you have to use the curly braces. Okay, clear? Do you understand?
Yes, very
Okay.
clear.
Okay, now we have another list that is color, and you can see these are the values of this list: red, green, and black. And we have one more list, number, and here you can see the elements of this list is 1, 2, and 3. Okay, and here we wrote 2 for each statement. So the first for each statement to iterate over the first list. Okay, and you can see the second for each statement, it is within the first for each statement. Okay, and here you can see the second for each statement, it will iterate over the second list. Okay, and then here we wrote a print statement: print x comma y. So they are asking you to write the output. So look, first it will take, here we have the loop variable. For the first for each statement, the loop variable is x, which means that uh, x will refer the first element of the list. Okay, so the first element is red. Then it will go to the second for each statement. Here we have a loop variable y. So y will refer the first element of the list number. Okay, so here x will be red and y will be 1. Okay. And the second for each statement need to be iterated completely. Once the iteration completed, it will go back to the outer for each statement. Okay. So initially, the value of x will be red and the value of y will be 1. Next time, the value of x it is same, but the value of y will be 2. And in the next iteration, the value of x, it is the same red, and the value of y will be 3. Okay, because there are three elements in the second list. So once the second list is completed, then the value of x will be changed. Okay, so what is the next value of x? It is green. Okay, so next time it will be green, and then the same as before, the value, the list of y will be iterated three times. Okay, so the first element in y is 1. Next time x, it is the same, green, and the value of y will be 2. Then next time it will be green and the value of y will be 3. Okay. Then the list of y is completed. Once it is completed, it will go and continue the outer for each statement. So next time it will take the next element in the list color, that is black. So it will take black, and it will iterate over the list y. So initially it will become 1, then x value is the same, that is black, and y value will be 2, and the last time black, and the y value will be 3. Now y is completed and x is also completed because all the elements are iterated. So the for each statement will be terminated. Okay, so that's why we got this output. Do you understand how we got this output?
Yes.
For all of you. Okay. Now, here, look at question number 4. Here we have a list called X, and the elements are 1, 2, 3, 4, 1. And here you can see we have three print statement. What it printed the first element, x of 0. Then the second argument is x of minus 1. That is the last element. Okay. So the first element is 1 and the last element is 1. Okay, so it printed 1 and 1. Look at the next print statement, x of 1 and x of minus 2. X of 1 is 2 and x of minus 2, that is the second last element. So the second last element is 4. Okay, so it printed 2 and 4. Then here we have one more print statement, x of 0 equal to x of minus 1, whether the elements are same. If the elements are same, it will return true, otherwise it will return false. Okay, so x of 0 is 1 and x of minus 1, it is also 1. So they are equal. If they are equal, it will output true. The same question was there in the other exam also. So I already explained it in the last class. I hope you understood it. Okay. Now we will go to the next question. Here we have three sets. Okay. Set 1, set 2, set 3. Look, because it is a set, we used Cayley brace. Okay. So the first set contains 1, 2, 3, and 5. The second set contains 4, 5, 6, and 7. Then set 3 contains 4, 8, 9, and 10. Okay, these are the three sets. Now, here you can see we wrote a print statement. Set 1 minus a set 2. So, set 1 minus set 2, it is the same as the difference operator. So, what it will give you? The unique elements of set 1. The elements in set 1, if they are not in set 2, those elements will be the output. So we can say that the unique elements of set 1. What are the unique elements of set 1? Here we have 1, 2, and 3, and these elements are not there in set 2. So we can say that they are the unique elements. Usually they will ask you to write the output. Up to now they ask to write the output. They didn't ask to write the code. Hopefully it will be the same, but I'm not sure. In case if they ask you to write the code, you're supposed to write the code. Okay. Okay. So the output is 1, 2, and 3. Again, here you can see they used the Cayley brace and they separated the elements by comma. Now, look at the second print statement. Here we have set 2 and set 3. So, when we use the AND operator, if you want to find the common elements in any two sets. Okay, so here the sets are 2 and 3. So, in 2, we have 4, 5, 6, 7, and in 3, we have 4, 8, 9, 10. So the common element is 4. So that's why the output is 4. Okay. And then we have one more print statement. Hanuf, it is not union, it is intersection. Intersection means the common elements. Union means all the elements from both the sets. I hope you understood the difference. Is it clear? Okay, okay. Now we have one more print statement. Set 1 dot is superset of set 2. Okay, so here they are asking set 1 is the superset of set 2. Okay, what is meant by superset? If one set contains all elements of the other set, the first set is called the superset. Okay, so look here, set 1. Set 1 has 1, 2, 3, and 5. Okay, set 1 contains all the elements of set 2. Set 1 contains all the elements of set 2. No. So we cannot say that it is a superset. So the output is false. Yeah, it contains only a part of set 2. Can you mute the microphone? Okay. So this is why we get false here. So this is about question 1. I hope you understood. Can I go to question 2? Okay. This is
Yes.
a okay. This is a normalization question. Here you can see, consider the following achievement report of a football team in different matches. The first part of the report contains general details of the team, such as team number, name of the team, country code, country name. The team plays different matches. The second part of the report contains the details of the matches played by the given team, match ID, name of the match, venue ID, name of the venue, city of the venue, and the medal won by the team in that match is given in this part. Okay. So this report, it is about a football match. So if you look at the report, we can find out the team number, the team name, the country code, the country name, match ID, match name, venue ID, venue name, venue city, and the medal won. And what they are asking you, normalize the report to 0NF, 1NF, 2NF, and 3NF. Show the complete relation with the given data in each normal form. Okay. So first we need to represent this report in 0NF, or we need to represent the report in UNF. Okay. So here uh, you can see we used a table, and in the table we wrote all the data in the form of rows and columns. Okay, here we have team number and here we have team name. Okay, so look here, team number and team name, and then here we have the country code and here we have country name. So we wrote country code and country name here. Then we have the columns as it is, match ID, match name. Here you have match ID and match name. And then we have venue ID and venue name, venue city. So you have venue ID, venue name, and venue city. And the last column is medal one. Here we have medal one. Okay. Now we need to enter the data. So here we have team number as S1 and team name as Musket Club. Okay, so look, S1 and Musket Club. And then country code, it is Oman, and country code is OM and country name is Oman. Okay, so we wrote OM and Oman. Okay, then we have match ID. Look, we have MO1, MO2, MO3. So here we wrote the values of match ID as MO1, MO2, MO3. And here you can see we repeated the same here. Okay, team number, team name, country code, country name. It is the same for all the match ID. Okay, I hope you know how to fill the table. So that table, it is the unnormalized form, or UNF or 1NF. Okay. Do you understand how we can represent the unnormalized form?
Yes.
Okay, what about others? Is that clear? Okay, now can you see the screen now? Okay, okay,
Yes.
okay, okay. So we will go to the the first normal form. Do you remember if it is first normal form, what are the conditions that we need to meet? We must have a primary key, and if we have repeating values or if we have groups of values, we need to solve it. Okay, that means if you look at the table here, check the team number column, team name and country code and country name. Here the values are repeating. Okay, so if the values are repeating, we need to remove those columns from the table. Okay, so this is what we are going to do here. Here we are going to remove team number, team name, country code and country name from the table. Okay, so here you can see this is table 1. We separated those columns from the original table. Then the other columns, these are the other columns of the table. So these columns will be in the other table or in table 2. So along with these columns, along with the match ID, match name, venue name, venue city and medal, we will take the team number column, because then only we can understand for which team they got these medal. Okay, for which team, where was the venue, the medal, everything we have to know. So we will take this column also from the original table. Okay, so that is table 2. Here we have team number and all the other columns of the original table. Okay, so now if you look at table 1, here you can see the values are not repeating. So we can say, and here we consider team number as the primary key. So we selected a primary key for the table, and each column has a single value, and there is no repeating values, there is no group of value. So we can say that table 1, it is in first normal form. Okay. Now we are going to see table 2, and here we consider both the columns as primary key. Okay, so why both columns as primary key? As I told you before, we need to identify which team got this medal, which team is related with which venue, and which team is related with which match. So we have to take one column from the team number, column of team number, and the other column of match ID. Okay, so here we take these two columns or the combination of these columns as the primary key. Okay, now we can, here also you can see S1 M1 unique value, S1 M2 another unique value, S1 M3 another unique value. That means no repeating groups of values, because this is the primary key. For this, it will take the combination S1 M1, S1 M2, S1 M3. So they are unique values. So here also we can say that we have a primary key for this table, and the values, each column has single value, no repeating values. So we can say that this table is also in first normal form. Okay, so these are the two tables in the first normal form. Do you understand how we converted the UNF into first normal form? For all of you,
Doctora, why you choose the name?
just choose the what?
The last column.
Last column means medal.
Yes, why you choose this?
In the first normal form table.
Yes.
The problem in the unnormalized form or in 0NF, what we are removing those columns which has repeated values. Okay, so here, wait a minute, let me show you the table. Look here, here these columns has repeating values. Okay, S1 is repeating in all the rows, Muscat Club is repeating in all the rows, OM is repeating in all the rows, and country name is repeating in all the rows. So what we did, we just remove those columns from the original table, and the other columns will be in the other table. Okay, so match ID, match name, venue ID, venue name, venue city, and medal, they will be in another table, and these four columns will be in a different table. This is the basic idea. Okay, clear?
Miss, I have a question.
Mm.
It is necessary in the exam to fill the table?
Yes, for sure. Because in the question it is mentioned to make the table with values. So if you did not give the values, you will be deducted some marks. So it's not necessary to draw the table like this if you don't have time, but you have to write the column heading and the values.
And
Okay.
should I write like the full value? Like, should I write Muscat Club? Can I just say M Club or not?
Ah, it's okay, no problem. You can use the short form, no matter. Okay?
Okay, thank you.
Doctora,
Okay. Yes.
will the question look a difference in the exam or only like this?
I'm
The
not
bill.
sure because it can vary. But these semesters in the last semesters they are asking these kind of questions. But I cannot guarantee that this semester you can get this type of question. I have no guarantee because I am not the one who is preparing the questions. The GCC from a different place, so I don't know how he is making the question. Uh, I will see the question once after you see the question. Okay. So I have no idea. What I can help you to explain the previous questions. You learn these type of questions. Hopefully, he will ask the same. Okay.
Okay, doctor, what else could come?
You mean for the normalization?
Yes.
They can ask any different format. Don't expect the same format. Uh, Maybe they can, for example, now you can see they give the data in a table. Sometimes they don't give the data within a table. It is like text. So you need to read the text and then you need to make the columns. Sometimes you need to put values from your side. Sometimes without values you can convert to normal forms. So like that, but hopefully he's asking these kind of questions for the previous semesters, so we can get the same, but I'm not sure. I cannot say 100 percentage you can get this type of question. I cannot say that. Okay. Okay, so let me complete. So now we need to convert the normal form into second normal form. Okay, do you remember the conditions of second normal form? Uh, if the primary key has only one column or one attribute, no need to check anything. We can say that it is in the second normal form. Okay, so here we have these tables. Look, this is the first table, table 1. And here we have only one column as the primary key. The primary key is team number. So it has only one column. If it has only one column, we can say that this table is in second normal form. Okay. So I can say that table 1, it is in second normal form. Why? Because the primary key has only one attribute. If it has only one attribute, then it will be in second normal form. Here, no need to check anything. Yes, very good, Rudab. Here, there is no partial dependency. Okay. Now, we will move to the second table. Okay. So, okay, this is the second table. And here we have two columns. Okay. The columns are team number and match ID. Okay. So, here we have two columns. So, if you have two columns, if any non-primary key depending on a part of the primary key, which means that these are non-primary key columns. These all columns are non-primary key column, like match name, venue ID, venue name, venue city, and medal. They are the non-primary key column. If any of the column depending on a part of the primary key, which means that if any of the column depending on team number, or if any of the column depending on match ID, then it is a partial dependency. And if there is a partial dependency, the table is not in second normal form. Can you tell me whether there is a partial dependency? Whether there is a partial dependency in the table?
Yes.
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 What is the partial dependency?
Middle.
Medal, only medal. Okay, I write here. Here I
Match
can
name, venue ID.
match ID will determine match name. Okay, I just write MNA because you can see M1 is only related with FA Cup, M2 is only related with the GCC Cup, and M3 is only related with the Premier, which means that each value of match ID related with only one value of match name. If it is like that, it is a dependency. Look, I can write MID determines M name. So this is what I wrote here. MID determines M name. Okay, which means that M name, it is a non-primary key column, and MID, it is a part of the primary key. So I told you, if a non-primary key column depends on a part of the primary key, this is called partial dependency. So if there is a partial dependency, then this table is not in second normal form. Okay, like that, here we can also check whether there is a dependency between match ID and venue ID. Match ID and venue ID. Yes, here you can see M1 is only related with the V1. M1 is not related with the multiple value. Like that, M2 is only related with the V2. M2 is not related with the multiple value. And M3 is only related with V1. It is not related with multiple value. If the left hand side is related with only one value of right hand side, it is called a dependency. So this is a dependency. Again, VID, it is a non-primary key column, and match ID, it is part of primary key. Okay. So again, a non-primary key column is depending on a part of the primary key. So this is not in second normal form. Like that, we can write match ID determines venue name. If you look, M1 is only related with Wembley, M2 is only related with Kassam, and M3 is only related with Wembley. So if one value of match ID, if it is related with one value of venue name, then it is called a dependency. So venue name, it is a non-primary key column, and match ID, it is a part of primary key. So again, it is a partial dependency. Okay, the same match ID determines venue city. So here you can see match ID determines menu name, venue ID, venue name, and venue city. So these are all examples of partial dependency. So if there is at least one partial dependency in the table, we can say that the table is not in second normal form. What about the last column, medal? Here in the question, they wrote a note. You have to read the question well. Uh, if you check, oh my God.
Medal won by the team in that match. is given in this
Read the
part.
question. Here you can see uh, the medal one, the last text, medal one by the team in that match is given in this part. Okay, and here you see they wrote something here. No. Okay, wait a minute. I read somewhere. Ah, yes. Here we have a note. Medal one means the medal won by the team in a match. Okay. So here you can see medal one means the medal won by the team in a match, which means that always you have to consider the notes which are provided in the question. So medal one column, it depends on the team ID or team number. Yes, because each team is identified by team number. Each match is identified by match ID. Okay. So from this knot, we can make a dependency. The dependency is medal one. It depends on the team number and the match ID. Okay. Or in other words, we can say that team number and match ID, it determines medal one. Okay. Which means that this column, it is completely dependent on the combination of these two columns. Okay. So here we cannot say that this is a partial dependency, because in the question, it is already mentioned that the column medal one, it is depending on both of these columns, or it depends on the combination of these two columns. Okay, so this knot you have to take care well. So because of this dependency, just 1 second. Okay, so what we do here, we wrote all the partial dependency. So what we will do, we will remove all these columns from this table. Okay, from table 2. What are the columns that we need to remove? We need to remove the match ID, we need to remove match name, venue ID, venue name, and venue city. Okay, so we will not remove the medal column because medal column is completely depending on these two columns. Okay, listen, here we are going to divide this table. So in the first table, it will contain the team number, match ID, and medal one. Do you understand why this table contains these three columns? Because all the other columns here, match name, venue ID, venue name, and venue city, they are the columns which is partially dependent on match ID. So we have to remove these columns from the original table. Okay. So other than these column, what we have in the table, we have team number, match ID, and medal. So that's why we put these three columns in this table. Do you understand?
Yes, it's clear.
Okay. Now, the other table. Look at the other table. Here you can see match ID, match name, venue ID, venue name, and venue city. So here I already wrote what are the partial dependency. So these four columns depending on match ID. So we took out these columns along with the match ID and we put them in table 3. Okay, now here we divided that table into two tables. This is table 2 and table 3. So now we need to identify the primary key. So in the original table, the primary key was team number and match ID. So here the same thing. And in this table, because this is the dependency that I wrote, Match ID determines match name. Match ID determines venue ID. Match ID determines venue name. Match ID determines venue city. So if you know match ID, then we can determine all the other column. So we will choose match ID as the primary key. That's why here we selected match ID as the primary key. Okay. Now we need to check whether these two tables are in second normal form. Okay. As I told you before, here the primary key is only one column. We have only one column, that is match ID. So if the primary key has only one column, then we can say that this table is in second normal form. Okay, table 3, it is in second normal form. Now, what about table 2? Table 2, here we have two columns as the primary key, but in the question it is mentioned that team number and match ID together determines medal. Okay, I already shown you that is medal. It is completely dependent on these two columns. So it is not a partial dependency. We can say that this is a full functional dependency. Okay, so because it is a full functional dependency, we can say that table 2, it is also in second normal form. Do you understand? Do you have any doubts, or if you cannot understand, just let me know. For all of you. Okay. Now we will move to the third normal form. So third normal form, it is based on transitive dependency. Okay. So just I remind you, if you have three columns in a table, then only we can make transitive dependency. Like if A determines B, uh, and B determines C, from these two dependencies, we can make a transitive dependency. That is, what is the transitive dependency? A determines C. Okay, so the common columns will be removed. The remaining ones are A and C. So by using these two attributes, we are making the transitive dependency. Okay, so this is what is transitive dependency. And if there is a transitive dependency between primary key and non-primary key, then this is not in third normal form. Okay, if there is a transitive dependency between primary key and non-primary key, then the table is not in third normal form. Okay, so let's check the tables in second normal form. Here we have, these are the tables in second normal form. Just let's take the first table. This is table 1. Can you find out any transitive dependency here? Look at table 1 and if there is a transitive dependency there. Okay, I have to stop at 10:30 because I am using one classroom and the exams, the midterm will start at 10. They need to prepare the room by 10:30. So I have to leave the room by 10:30. So let me explain. Here the primary key is team number. By team number, we can find out the country code. Okay, you need to understand one thing. If there is a primary key, by that column, we can determine all the other columns in the table. Okay, so team number can determine team name. This is a dependency. Team number can determine country code and team number can determine country name. This is a rule. If you have a primary key, by that primary key, we can determine the other columns. Okay, so this is the first dependency. Then, if you know the country code, can we find out the country name? So we can write one more dependency here. Country code determines country name. So now, from these two dependency, can we make a transitive dependency? For example, these are the common column. I delete the common column. So the remaining, the team number and country name. So I wrote team number determines country name. So here country name, it is the non-primary key and team number is the primary key. So before I told you, if there is a transitive dependency. So this is a transitive dependency, and if there is a transitive dependency between primary key and non-primary key, the table is not in third normal form. Okay, so table 1 is not in third normal form. It is not in third normal form. So what we will do, we need to remove country code and country name from this table. Okay. So what are the columns? In one table, we have team number, we have country code, and we have country name. Okay. So these are the columns of one table. Okay. And the other table will contain just the team number, the team name, and country code. It will not include country name. Okay. So that will be the next table. Okay. So this is what you can see here. Yes. Here we have team number, team name, and country code. And here we have country code and country name. Okay, look at this table. This is table team. And by before what dependency we had? We had team number determines country code. And we had one more, that is country code determines country name. Do we have this dependency? This dependency in the table team? No. So we can say that the table team, it is in third normal form. Okay. And here, this is a table country. And here we have only country code and country name. So here we can make only this dependency. Country code determines country name. Okay. As I told you, if you want to make a transitive dependency, we need three columns. We need A, B, and C. But here we have only two columns. So by these two columns, we cannot make a transitive dependency. Since we cannot make a transitive dependency, we can say that this table, it is also in third normal form. Do you understand? Okay. Okay. Now we have this table. We need to make sure whether the table is in third normal form or not. Is it in third normal form? Look, here we have match ID. Ah, very good, Ahad. Match ID. And match ID can determine venue ID. And match venue ID can determine venue name. So from these three, we can make a transitive dependency. I will write it here so you can understand. Match ID determines venue ID, and venue ID determines venue name. So what is the dependency? Yes, here you can see from these two, we can make okay, match ID. So I delete the common. Then what we have? We have this. Match ID determines venue name. Like that, we have one more. Match ID determines venue ID, and venue ID determines venue city. So what we will do? Remove the commons, and what we have sorry, match ID determines venue city. So here we have match ID determines venue name, and here we have match ID determines venue city. So what we need, we have to remove match ID, venue ID, uh, sorry, we need to remove venue ID, then venue name, and venue city. So these columns will be in one table, and the other columns will be in the other table. Okay. So this is what you can see here. Here we have match ID, match name, and venue ID. And here we have venue ID, venue name, and venue city. Okay. So now we can say that here by in the table match, it is in third normal form because we cannot make a transitive dependency in match. Okay. What we can make only this match ID determines venue ID. But by venue ID, can we make it a dependency in that table? No, we don't have venue name here and we don't have venue city here. So by venue ID, you cannot make a dependency. So this table, it is in third normal form. Okay. And what about this table? Here the primary key is venue ID. So venue ID by venue name. But by the right hand side of this dependency, we cannot make another one. Okay. So what we can make here, venue ID determines venue city. So from these two, we cannot make a transitive dependency. When we can make a transitive dependency, that means if the right hand side of the dependency, if it is the same as the left hand side of the other dependency, then only we can make a transitive dependency. So here we cannot make a transitive dependency. So we can say that the table venue, it is also in third normal form. Okay. So now we made the tables. We converted the tables into UNF, unnormalized form, 1NF, 2NF, and 3NF. Okay. You had an idea, you got understood. VN depends VCT. Venue name, it depends on venue city. Yes, it is a dependency, but by this we cannot make a transitive dependency. Okay. Do you understand? Rudab, is that clear? Why? Because each value of venue name is related with one value of venue city. So if it is like that, this is a dependency. Okay. Uh, if you get VID, you can get name city. It's not like that. If one value of, for example, if I write this dependency, venue name determines venue city, each value of the left hand side, if it is related with only one value of the right hand side, then this is a functional dependency or it is a dependency. Is that clear? Okay. Okay. So this is all about part one. Now we have one more part here. What we need, you have to write all the tables and we have to write what is the primary key of each table and what is the foreign key. Okay, so we will start from here, venue, and this is the primary key because you remember by venue ID we can determine venue name, by venue ID we can determine venue city. So we will choose venue ID as the primary key. Okay, so we wrote venue ID as the primary key and there is no foreign key. Okay. Okay. And then we will go to the next table, that is the match table. So, so look, this is the match table. Here we have the primary key is menu ID, sorry, match ID. So we write match ID as the primary key. And look, here we have another column, venue ID. And we know that venue ID, it is there in the table venue. So we can consider venue ID as the foreign key. So like that, you can choose the foreign key and the primary key. Okay, so here you can see in the table venue, we have venue ID as the primary key, but in the other table, venue ID as the foreign key. So if you have a primary key in a table, and if you use that primary key in a different table, then that will be the foreign key. Do you understand? Okay, now we have another table, result. Okay, so here we have result and look, team number, it is from the table team and match ID, it is from the table match. So in this table result, it is the primary key because by the combination of these two columns, we can determine each row. So here they are primary key, but at the same time, they are the foreign key because team number is not the column of result and match ID is not the column of result. We took team number from the from the table team, and we took match ID from the table match. So both of them, they are primary key, and at the same time they are foreign key. Okay. Now here we have country. In the table country, the primary key is country code, but here we don't have any foreign key. Okay. And the table team, in the table team, the primary key is team number. And here we have country code. We took a country code from the table country. So country code will be foreign key in the table team. Okay. Is it clear?
Yes.
Okay. Then we have one more table here. In the table 3, here we have match ID, match name, venue ID, venue name, and venue city. So here in the table 3, okay, no need to consider table 3 because they ask you to write the foreign keys and primary key of the tables which are in the third normal form. Okay, so you have to consider only the tables which are in the third normal form. Okay, that's it. So that's it. And we have one more question that is SQL based question. Actually, this is the same question that we explained in the last master session. So I hope you know how to answer the question. So I will skip it now. Okay. So that's all.
Miss, do you have the past paper for summer? Like this summer or not?
Sorry, I didn't hear you.
Do you have the do you have the past paper for for the last summer, the midterm of summer 2025 or not?
I don't have. I saw that you already sent an email, but I didn't get the time to read it. I will read it and I will reply